Hi everyone. Hi everyone, Senan this side, and in this video we are going to solve this LeetCode daily problem, which is minimum number of days to disconnect island. Okay, so you are given m cross n binary grid where 1 represents land and 0 represents water. An island is a maximal 4 directionally connected group of ones, right? So if there is a 1 left or right or up or down, that is the part of the same island. Okay, and we need to find the minimum number of days to disconnect the grid. Okay, so I think yesterday only I solved a question minimum, not minimum but number of islands in this matrix, in a matrix, right? So the logic would be same, and we have to use that function as a helper function in this problem to solve this. Now let's say if the graph, we treat this matrix as a graph, right? So let's say it is already disconnected. So in that case what we have to do is just return 0, right? Because if the graph is already disconnected, that is, we don't need any days to actually disconnect some island, right? And what we are allowed to is to change any single land cell 1 into water cell 0. That is fine. So basically we need to find the number of cells that we are going to convert 1 to 0 such that the resultant matrix would be a disconnected graph or disconnected islands. Now initially, if you think of a brute force approach, your only objective would be to try all possible cases, right? And then count the number of islands in that. And that is a good approach, but the only way that fails is you need to find the minimum number. And if you think this, that why minimum, so this actually makes the question a lot more simpler. So I told you that if the matrix is already disconnected, the answer would be 0, right? And let's say, what if rather than disconnecting the island in any way possible, let's try to see what are the minimum number of days that we actually require in the worst possible case. In this case, we have to disconnect these two islands, we need to remove this one and this one, right? Then only then the islands would be disconnected. Okay, so we need 2, and let's say this whole 3 cross 3 grid is covered with 1. Then what would be the minimum number of days to disconnect the grid? And the most brute force thing that would come to mind, like use the diagonal, right? So 1, 2 and 3, so you would require 3 days to disconnect this grid. But where this argument fails is this is not the minimum number of days, because rather than, let's say, if 3 cross 3 is all ones, we just need to disconnect this and this one and this one, and there would be then 2 islands, this bigger island and a single cell island. So if you try any possible case, either the answer would be 0 if it is already disconnected, it could be 2 if it is a complete, or it is a rectangular matrix of 1 comma 1 of 1 only. In that case it would be, the answer would be 2. Otherwise the answer could only be 1. Let's say if we have an L shape, let's say like this, we just need to remove this, right? So then we would have 2 disconnected portion. So if you realize, and if you try to draw many different examples, you would find there are only 3 possible answers for this question, either 0 or 1 or 2. there are no other answers, right? So let's say first of all we would find the number of islands in the matrix itself in this grid, and if in that case it comes out to be either 0, it's totally water, or it's 2 or more than that, then the answer is 0 because it's already disconnected, right? And to do that we would write count islands, a separate function, and we'll see how to do that. First of all, I would take int n as grid dot size, the size of the grid, and I'll take m as grid of 0 dot size. That is, this is the row, this is the column. Now I say let's check if count islands is not equal to 1. That means we have either 0 islands or 2 islands, so it is already disconnected. Why 0 is disconnected? Because grid full of water is also disconnected. So this question basically asking there should not be exactly one island, right? So if that is the case, I return 0, and in the end I would return 2 if for some reason we are not able to disconnect the island by removing a single cell. Now to check that if removing a particular cell would disconnect the island, what I would do is I would take this grid and I would remove a particular element of that. Then I would count the number of islands in the remaining grid, right? And if we are able to get islands more than 1, then we are good to go, right? So what basically I would do is traverse the whole matrix for int I is 0, I less than n, and I plus plus, for int j is equal to 0, j less than m, and j plus plus. Now what I would do is I would check if grid I and j is 1. So rather than doing this, we can just do this. So if this is 1, we know that we can possibly remove this element or this cell and then count the number of islands. So I would specifically say grid I and j is equal to 0. I'll remove this as an island. I would check if count islands, and yeah, this would be a function, and this would take the grid as an argument because we need the grid, right? So grid is not equal to 1, then I would return 1. And if that is not the case, I would update the grid to, I would restore the grid basically. And what this would do is this for loop will go to each and every cell in the matrix which is 1, and it would for a moment remove that island and check if the island gets disconnected. If not, we would restore that value and do this for the next cell which contains 1. And this is done. If you would run this code, this would work, but we need to write the count islands function first. Let's do that. So, or int count islands, and this would take the grid as an argument, and what it would do is, first of all, every time we need the sizes, so rather than taking that as an argument, we can take that from the grid vector. Okay, fine. Now we need int islands, is equal to 0. Initialize the number of islands to 0. What I do is go to each and every element. Int I is equal to 0, I less than n, I plus plus. For int j is equal to 0, j less than n, and j plus plus. And then what I do is I check if grid I and j is what? Is 1, that it is a valid grid, and it is not visited, right? I and j. So to do this, we need to have a vector of vector int, basically a visited matrix of the same size is equal to, or visited, and size is n comma vector int m comma 0. So if that is the case, what we do is we now call a DFS on I comma j comma visited comma grid. Fine. Now to do this, we need to do DFS, right? So every time we call a DFS, we increase the count of island, and I would say return islands, and this should work. This should be m, not n, ij visited, and grid. Now one more thing. To do this again, we need to write the DFS function. So DFS would be void DFS to take int row, int column, and it would take this grid and the visited array. Make sure you pass it by reference, right? Otherwise it would be incorrect, obviously. Okay, so what I do is, okay, first I need to check that is this a valid call or not, right? So again, I would take this and paste this here, just to get, or just to write code that is easier to read. So if I say if row is less than 0 or call is less than 0, so either they are invalid indices, or row is greater than equal to n, or column is greater than equal to m. That means we are, so if either of these 4 conditions are true, that means we are not in the grid itself. Or let's say if we are in the grid and we have already visited it, row and column, then also we don't do this DFS. And finally, if grid of row and column, if grid is 0, that if this is grid is 0, and using this not operator, if grid is 1, okay, no, so if this is 0, then not of this is 1. So if either it is a water, this node is containing water, or is already visited, or is outside the matrix, what we do is just return, and we don't perform the DFS. Otherwise, what I would do is call DFS for row, column, visited, and grid, but for all the 4 directions: +1, -1, +1, -1, and let's just format this code. Okay, So basically we take the size, we check if it is either outside the matrix, or it has already been visited, or it is a water node, we just return. Otherwise we call, so if we come after this if statement, that means we have a valid node. So we call the DFS on its neighbors, and that would do the job. Let's just run this and see if there is some sort of an error. Runtime error. Okay, there is okay, did we do something wrong? Okay, yeah, obviously we did forget the most important part is we need to mark this row and column as 1, because we have visited that node, so we mark this as 1. This should work. Yep, accepted. Right, now let's just submit this. Okay, now what is the time and space complexity? Right, so the time and space complexity is m times n times whatever this count island is taking, and count island is taking what? M times n plus m times n for DFS. It's not a multiplication in this for loop, it's basically addition. So maybe the time complexity is m square n square, or in a way, if there are n nodes, which is m times n, so capital N, let's say capital N is equal to m times n, then the time complexity would be n square. I think so that is the correct solution. What is the space complexity? Space complexity is of DFS, that is m times n, right? So at max you would go to all the nodes in this recursion stack space, and that would take all the space, which is m times n, and again we took a visited array of size n times m, so space complexity would be 2 times n times m, and we are updating this grid, again counting the island on the whole grid. So this is taking m times m n time complexity, count island is taking again m times n for this for loop, and m times n for this DFS, which is m times n plus m times n for this DFS, the worst case. So yep, that was the video. Hope this helped you. This was a LeetCode hard problem, but it was basically a depth first search, or you could also use breadth first search as well to find the number of islands. And we did this count islands in the previous video, right? So that is the whole video. Hope this was useful to at least one of you, and yep, thanks for watching and bye.